Okay, so I call this section, this particular section, you should have this on your study sheet when it comes to finding the height, because quite often I just throw it in there, like, hey, find the height of this cliff, find the height of the tower, find the height of, so you have to have this ready to go. So I will explore it here, but really we're going to have a shortcut later on for finding the height. So the height in this case is just a dashed line. It's not actually a side of the triangle, but the height is always makes a 90 with respect to the ground. It goes all the way to the highest point in this case. Morning. So this little note here, height is measured perpendicular to the base. Okay. So let's determine the height of this triangle. Always remember, now that we insert the height, we've got a bunch of triangles happening. I don't know if you see it. You've got the big one here, ABC, and then you've got that right triangle right there. You've got another right triangle right there. What you need to remember is don't mix up triangles. Don't mix up triangles. What do I mean by that? If you go sine of 33.4 over this side, right, then you're using this angle and this side. Now you're technically in the big triangle, right? So don't be saying, oh, I'm going to pair these ones up, and then I'm going to go sine of 59.8 and find the height. Wait a minute, this pair is where? In the small triangle here. Okay, so don't mix up triangles when you do sine law. Okay. The point that I want to make here is we're going to find the height twice. I don't expect you to do that down the road. Okay, let me just get my key ready to go here. So I don't, let's approach this from coming in from the left here. Okay, we know that if there's a 90 here, there's also a 90 on this other side, because if you have a straight line that adds up to 180. So I don't need to put the 90 on both sides. Okay, so that's first part right here. So if we take that triangle out, let's just sketch it here. Okay, sketch the triangle, and we're going to cut it out where this is our height. This angle 59.8 comes with us here. 59.8. The 4.52 feet will also come with us. Question, will the 8.2 follow us? No, right? It belongs to the big triangle. We can't use it, so leave it. Okay. So this is all we have. What would we use to solve for h in this case? What law? Sine law, right? Because you have a pair here. I always want you to know that, right? These are paired up like this. And so this angle is going to allow you to find the side across from it. Okay. So let's do that. I'll just give this slant a color. That green is right here. And the height is right here. So those are the two sides that are coming with us. So we're going to go sine of 90 over 4.52 feet. I'm quite certain that at this point most of you would already know, yeah, I know how to find it. Okay. Sine of 59.8 over h. Okay. And then we just solve. You cross multiply and divide. So it's 4.52 times sine of 59.8 divided by what? Sine of 90. And do you remember what that is? Sine of 90? Did I talk about it? Sine of 90 is always 1. So if some of you might be surprised if you go 4.52 times sine of 59.8, right? And then you go divide it by sine of 90. Watch, nothing is going to happen. It stays the same, because sine of 90, if you just type in sine of 90 on its own, it's always 1. And you don't need to remember that. You just need to be okay with it. If you divide and you get the same answer, it's not like you're doing something wrong. It's just that sine of 90 is 1. So if you need to make a little note here, sine of 90 is always 1. And so in this case, our height is 3.91. Okay, we got that. That is the height of this triangle. So let's approach it from the other side. And let's give it a different color. So I'm going to quickly draw this triangle. 33.4, 7.1 comes with me. Height, it should be the same, right? Our answers? Okay. It should be. And the 90 is here. 90 is very useful, right? So we've got our pair, angle, and then this one will allow us to solve for this side right here. So again, sine of 90 over 7.1, and then it's sine of 33.4 over height. And so you multiply here, 7.1 times sine of 33.4 divided by sine of 90. Just in case you won't believe me, okay, I'm not going to bother dividing by sine of 90. I'm just going to leave it like that. 3.91 feet, so I get the same answer. Okay, let's, I'm going to try to highlight the 7.1 is right here. And the 4.52, that's the green, is right here. You see a pattern already or not yet? Let me see if I have another pencil here. To find the height here, we grab the slant side right here, and what did we multiply it by? Sine of the angle that's touching it. That gave us the height. And you're like, what about sine of 90, Mr. Dirksen? Well, that's 1, so why would you bother doing that, right? It just wouldn't change anything. Let's come from this side here. How did we get the height on this side? We took the slant and we multiplied it by sine of that angle that is right there touching it. That's how we found the height there. So that's, if you see that, it's going to save you some time. If you don't see it, you just do exactly what I did here. Okay, you just maybe sketch it quick, find your pair, do sine law, and you get it. But I'm here to tell you that quite often we're just going to find it doing the pattern. So here is the short version for you. Okay, short version is right here. How do you find the height? You take the side. I'm going to rewrite this a little bit. Maybe side length, I'm going to put an arrow to that one. Maybe I can fit it in down here. Slant. Slant length, right? Slant side length times side of the adjacent, sine of the adjacent angle. Adjacent is just a word we use that it touches it. Okay. It's going to touch the side length. So this is the shortcut. If you want a study sheet entry, maybe this is all slant times sine of angle. Maybe that's all you need on your study sheet. It doesn't need to be this elaborate. Okay, you can see that there. Hold on. This is the short version of it. And I'm going to help you out here. Maybe you pick one of the triangles that I'm about to show you down here, right beside this formula, so you know what am I talking about there. So for example, over here, if you looked at this triangle and I asked you for the height, I would just say this: height is side PQ times sine of what? Which angle? Which one is touching PQ? This angle right here. So it'd be sine of P. what's the alternative? What's my other way to do it? Height is, if I come from this side, what's the slant? It's QR, right? Or RQ? QR code. Hey, that's a good one to remember. Times sine of R. If you can remember that, it's going to save you tons of time. What about this triangle? Upside down. I can't do this, Mr. Dirksen, upside down. It's okay. What's the slant here? So if you were to come from this side, DF, correct? DF is the slant, so you just go height. I think you're like, don't make such a big deal. I got it already. I'm just sleepy right now. Sine of, it's not F, right? It's not this one. Make sure you know it's not this one, because it's also touching the slant, but it's the angle that connects to the straight horizontal line, right? So it's sine of D. And what about this one? It's outside the triangle. What's going on here? The height is outside the triangle, so it's kind of weird. It still works. You would take QP. Height here is QP times sine of, which angle would you think? If it's QP, yes. Or H is found by going QR, okay, this one out here. QR, if you get, then you have to go sine of R. I hope you see the pattern. So all of this just to get to this, but if I just gave you this formula, I don't think you would have just maybe taken it, but I want you to understand where these formulas come from. Technically, all of these ones have a sine 90 underneath it. Sine of 90, just like here. But does it help us, the sine of 90? Does it matter? No, because it's 1. Okay, so we won't bother with it. Is this gonna throw you off if there's no or here? I'm just gonna do this just in case. EF times sine of E, if you need an or there. So this part right here is what this short lesson is all about. It's just really coming down to this. So and if you like highlighting, I'm just going to do it for one, right? Just one of these. I'm going to say I take the slant and I multiply it by sine of P. So I'm just going to highlight this angle right here. So maybe you just need one, just this one right here, next to this formula right here. And maybe for you, right, you need slant written on this one. Okay, so I'm trying to help you out because I know your study sheets are limited in space and sometimes you need a bit of a help figuring and some of you might need all three of these on there, I don't know. But don't worry about, I would say this coupled with that and the formula, right, it would for me be enough. Okay, and I'm going to squeeze in one example here on page 18. Let's go to 18 and just do that first one here. Maybe I will ask you to try this one first. If I asked you to solve that triangle, could you do it? I'll do my attendance real quick. Look at this. It seems as though you couldn't at first, but there are markings on there. Can you solve that triangle? Can you at least get it started? Okay. And then we'll find the height once it's all said and done. Guess I have other things in mind yet. I'm going to just jump into this one. So if the markings are here, if this is 15.9, so is this one. Okay. So we have an SAS scenario here. But if these two sides are the same, what do we know about the angles across from them? these are also going to be the same. It's an isosceles triangle. If it's an isosceles, I only need to give you one angle and you technically know them all. Okay, so angle X, which is the same thing as angle Y, could be found by going 180 minus 72 and then split that in half. Okay. So you get, for this you get 54 degrees. And so you have a choice here. You've got choices. This is 54, so is this one. So you could use sine law if you wanted to, right? This is, which pair do you want to use? It's up to you. They're both the same. You could use this as your pair, and then sine of 72 to figure out this side here. Okay. You've seen a lot of sine law by today, so how about I try cosine law? I'm just going to say SAS here. Side, angle, side, right? So you could say, call this Z here. So Z squared, how does it go again? 15.9 squared plus 15.9 squared minus 2 times 15.9 times 15.9 times cosine of 72 degrees. Okay, so Z is going to be square root of all of that. Sorry, I used sine law on mine. So I'm going to go 15.9 squared plus 15.9 squared minus 2. Thank you. That's 349.3748 something. I take the square root of that. Don't erase it if you use sine law, okay? This is fine. 18.69. And that is miles. So we've got, we solved the whole triangle with basically two steps. You can say that. Okay, we know all angles, all sides. Done. Okay. Did you get that? Kelly, you asked me about, you did sine law, right? Did you get the same answer? Okay. Yeah. So sometimes I throw this at students on like a quiz or a test, and I think it's so basic, but I didn't talk about it, and then you freeze on this one. Don't freeze on this one. You can solve it. It's just a little knowledge of isosceles triangles, right? That's all. Okay, I'm going to stop here.